Ah, sprites. Sprites are awesome. Sprites are those little characters that you see in video games like Mario, Thor, or Sonic. They're just graphics that float above the screen or behind the screen. They're not a part of the character set, they're just there. And in this video, we're going to explore how to program sprites on the Commodore 64 in BASIC. So, what exactly is a sprite? Well, on a Commodore 64, a sprite is a 24 by 21 single color bitmap that can pretty much be positioned anywhere on the screen. Optionally, it can be a 12 by 21 multicolor bitmap. The Commodore 64 can display 8 sprites at once. I'm going to put a giant asterisk on that last statement. There are ways to overcome those limits, but we're not going to discuss those in this video. Each of the 8 sprites can have its own shape, X and Y position on the screen, its own color or colors, can be doubly wide, doubly height, or both. And they can be in the front of or behind text. And there's facilities to detect if sprites collide with each other or text on the screen. In short, sprites are cool, and they're great for writing games, or for making mouse pointers out of, or just anywhere where you need a graphic. So how do we program sprites? There are no commands directly in Commodore BASIC to interact with sprites. So we are forced to interact with the VIC2 chip, that's the video interface chip, directly to control sprites. So it seems a little intimidating because the way you interact with the VIC chip is through 47 registers that are exposed through memory addresses 53248 through 53294. So we had to peek and poke values into those different memory addresses to make sprites do things on the Commodore. So let's just get started, and right off the bat, let's turn on a sprite. There are 8 sprites that we can pick from, numbered 0 through 7. And the way that we enable sprites is we poke a value into 53269, and we tell it which sprite we want to show on the screen. Because it's an 8-bit value, as you can imagine, each individual bit acts as a light switch to turn the sprite on or off. We're just going to work with sprite 0 today, and all we have to do is set this value to 1 to turn that sprite on. So let's press enter and see what happens. Looks like nothing's happened, but I assure you the sprite is actually turned on. It's just positioned in such a way that we can't quite see it on the screen. The default XY coordinates of the sprite are 0, 0. Each sprite has a pair of memory addresses that control the X and Y positions of that sprite. For sprite 0, they are at 53248 for the X value. I'll press enter here, and still don't see anything. So maybe we moved it over, but it's not down far enough. So let's poke 53249 with 50, and there's a sprite. It's on our screen. So at 53248 and 53249 being the X and Y coordinates of the 0th sprite, as you can imagine, the next sprite is at 50 and 51, 52 and 53. But we only care about sprite 0, so this is fine. So we've got our sprite on the screen. And there, as you can see, it's a single color. The default color is white. It's blinking, which is kind of interesting, and we'll explore that more in just a moment. But we can make the sprite bigger. We can tell the VIC chip to make the sprite twice as tall. And there's a memory address for that, as you can imagine, and that is 53271. This memory address, just like the one that turned on and off the sprites, has a bit for each sprite. And you can toggle extended mode by putting a 1 in a sprite you want. So we're going to put a 1 here, and now our sprite is twice as tall. There's also a memory address for making it twice as wide, and that's at 53277. So if we put a 1 there, now our sprite is twice as wide. Well, let's clear the screen and see if we can get a closer look at this. We can just see garbage on the screen and just a little flickering block of something. Well, each of the sprites needs a place in memory to describe the shape. And by default, all sprites are pointing at memory address 0 for its shape. Memory address 0 in a Commodore 64 is a part of what's called 0 page. So what you're seeing here is a live window into the first 64 bytes of memory. And because the VIC chip is constantly scanning that memory for the shape, you're seeing activity in that area of memory real time on the screen by looking at 0 page. Let's take a step back and talk about the sprite shape. A sprite is 24 pixels across, single color mode. Each pixel is represented by a bit. So that's really 3 bytes across to get our 24 pixels across. And of course, 21 down. 3 bytes times 21 bytes is 63. But where's that extra byte? Because we did say 64. Well, there's an extra byte that's just not used. And it's because it's very convenient to pad each sprite to 64 bytes. So you can use that extra byte for whatever you want to store there. So how do we tell sprite 0 to get its shape from somewhere else? Well, there are 8 memory addresses 2040 through 2047, and each one we can store a value to change the location in memory of where the sprite is going to draw from. So 2040 is the memory location for sprite 0. So if we change this to a different one, let's say we change it to page, let's put the value 2 there. Oh, we get a different block of garbage with some different blinking lights on it. So the value 2 does not mean start at the second byte of memory. It's really the third set of 64 bytes. So when we had a 0 there, it was 0. If we had placed a 1 here, it would look at memory addresses 64 and on. And then if us placing a 2 here, we're looking at memory addresses 128 up to, I think it's like 192. Now what's interesting is those really fast blinking bits there. Because we're still looking at 0 page, we're looking at addresses 160, 161, 162 in that little spot there. And what you're seeing there is the Jiffy clock in real time. That's right, you're looking at the Commodore 64 counting up from 0 endlessly. And if we reset that to 0, you could see that it's reset to 0, and you could see it counting up again. Kind of cool. Well, that's all fun and all, but we want to actually create byte data. And what you can see from this small exercise is there's not a whole lot of places to put sprite data. The highest number we can put into this value is 255, and 255 times 64 is 16,320. And that means we can fit only 16K of sprite data. But my Commodore has 64K of RAM. Well, the VIC chip can only see 16 kilobytes at a time. And by default, when you turn the machine on, it can only see the first 16K. Now you can configure the VIC chip to look at the other 3 different 16K regions in a Commodore 64. But for this video, we're just going to stay in the default first block. So where can we put our sprites? Well, there's a tiny bit of room in a tape cassette buffer, and we're going to use that for this video. This way we don't have to reconfigure memory or do anything crazy. There's just enough space in a cassette buffer to fit about 2 images. The cassette buffer happens to be on number 13. So if we set this to 13, we get a blank page because there's nothing there yet. So the cassette buffer ranges from addresses 828 to about 1019. 13 times 64 gives us 832. 832 plus 128 is 960. So as you can tell, we could fit about 2 images into this little spot, and that's all we need for our demonstration. So now we're pointing at that memory location, and we have nothing there. If you look at the bit pattern 10101010, as you could imagine, if we were to fill this pattern with that, we should get a jail bar look. So we're going to fill in 0 to 63, and we're going to poke memory just 832. That's where the beginning of our sprite block is, plus n, comma 170. And voila, our sprite is now a bunch of jail bars. And if I move my cursor here, you can see by default, the sprite is in front of the cursor. So if I were to put reverse video on and try to build a little jail cell out of this, it wouldn't look that great because the jail cell is behind the bars. Well, there's another memory address, 53275. And this memory address has a bit for each of the 8 sprites. And once again, we're working on the 0 sprites. We have to do toggle that first bit. By default, it's off, which means the sprite is in front of the text. And by setting it to 1, the sprite is now behind the text. So you can control where the sprite is in relation to text on the screen. Well, this is fine and all. Let me clear the screen here and get over here. But so far, we're working with sprites of just one color. What about multicolors? Well, there's another memory address, 53276, that controls whether each sprite is in single color mode or multicolor mode. And as you can imagine, all we have to do is set that value to a 1 to turn the sprite into multicolor mode. So we'll press enter. And now my sprite is a solid white square. Not exactly multicolor, but we'll get there in just a moment. So multicolor mode is a trade-off. In single color mode, we have 24 pixels across. In multicolor mode, it will be only 12 pixels across. However, each pixel could be one of 4 colors: a background color, a foreground color, which we can choose for each individual sprite, or one of 2 colors that are shared amongst all 8 sprites. So let's make a bit pattern showing each individual color. So once again, using my calculator here, we're going to start with 0, 0, 0, 1, 1, 0, 1, 1, and that number is 27. We're going to fill all 63 bytes with 27, and that will make our sprite multicolored jail bars. So once again, we're going to do for n equals 0 to 63. We're going to poke 832 plus n, comma 27, and colon next. And there we see one of each of the possible colors that is currently configured by default: a purple, a white, a black, and the background color, which at the moment is blue. There's something called the shared color 0, or sprite other color 0, and that's at 53 to 85. And by setting this to a value like 2, which makes it red, that's our second color. Now all sprites share that same color. So if you had 8 sprites on a screen, they would all have that second color as red. The other shared color, which is stored at memory just 53 to 86, we can set that to a different color, like 7. And now we have red, white, and yellow. And now we have multicolored sprites. Cool. So let's put this all together now, and let's write a program that's going to animate a sprite. Now we can create sprites by hand, with a graph paper, and we got to calculate the bit patterns into bytes, then put together data statements, but that's way too much work. There was a fantastic program available as a type-in program going all the way back to August of 1984 called Sprite Magic. It was written by a person named Charles Brennan, who also wrote actually the Automatic Proofreader, MLX, Ultrafont Plus, and of course the legendary SpeedScript word processor, which were all type-in programs from that era. So this is another one of his great works. Well, first you got to type it in, and I actually did type it in, not because I couldn't download it off the internet. I really wanted to relive the experience, and it only took me 3 or 4 hours to key it in, so it really wasn't too bad. And you're definitely going to want to refer to the magazine, which is available in PDF on the internet. I'll put a link in the notes so it's easy for you to find. So let's load it up. So we load it up, comma 8, comma 1. This program resides at memory just 49,152, which as you can see is just outside the reach of BASIC. So what's really nice is you can use this program and write your BASIC program at the same time. Once you load it, you should type new. This way BASIC is ready to go. And we're just going to start with a simple line of code. Line 1000, rem sprite 0. The reason why you want to put in that line there is when it creates the data statements for you, it starts normally at line 1. Here it's going to start at 1001. So this way we can put our basic program ahead of it. Now let's switch into Sprite Magic and make a sprite. So we type sys 49152. And here it is, Sprite Magic. What you'll see here is a blinking cursor. That's my cursor. We are in a single color sprite. So there's 24 pixels across, 21 down. So it's kind of a square. On the top right, you're going to see a number. That is the, I guess we'll call it a slot, the multiple of 64 memory location that we're in. So we're in 255, and 255 times 64 is 16,320. So this is the last sprite that we could possibly have. Now you can press plus and minus to go between the different ones, and you'll see that they're mostly the same garbage pattern. Every so often you'll see a different one. For what we're doing, it really doesn't matter which one we're doing it in, so we'll work with this one. So we can press home to move the cursor to the top. I'm using my cursor key to move the cursor. You can press shift clear to clear the sprite out, so don't have an empty sprite. And then we can just use the space bar to toggle the bits. So as I just said a moment ago, this is a single color sprite. We don't want to do that. We want to do multicolor sprite. So we're going to clear it. We're going to press F5, and that's going to put us in multicolor mode. Notice how the pixels are now twice as wide. But now we have 4 colors available to us. So we have the white that we know about, and we could press the number keys to change between the colors. So we have white, which is 2, You press 3 to get the shared color, the first shared color, and 4 to get the other shared color. So it's purple and cyan. If I wanted to set it, I would press Shift 3 and then type in a color combination like Control 5 or Control 2 rather. Oh, that's probably a bad example. Shift 3, Control 3. There we go, red. So now we have different colors here that we're working with. Let's attempt to make a car. And I have to warn you, I am a really, really bad artist. So please forgive me for the atrocity that I'm about to create on the screen that is supposed to resemble a car of some sort. Oh boy, this ain't looking too good. Let's use red for the windows here. Actually, let's use purple for the windows. And then we'll make the rest of the car red. There we go. I guess we'll go back to purple for the tires here. All right, there's our car. I did warn you I'm a bad artist. Now, with this sprite memory, all you do is press Control D, and it looks like nothing happened, but it just added data statements to our basic program. Now we could press Control X to exit out, and we're back in basic. And if we type list, there's our first sprite. Now if we wanted to make another sprite, we can put a line maybe 1100, we can call this sprite 1. We could jump back into the sprite editor with sys49152. Now we're back in here. Now it looks like it broke our sprite, but what we did is press F5 to get back to multicolor mode, and we're back. And let's see if we can make, I'm not sure how to animate this. Let's see if we can make the tires look different. I'll tell you what we'll do. We'll make, I don't know, that is, I guess is going to be the best I can do to make it look like the tire is rotating. Oops. All right. And then I'll just press Control D again. That will append data statements for our second sprite to our program. Control X out of here. And now our basic program has data for 2 sprites. So let's create a program to use our sprites. So let's see, let's make the background color of the screen black. 53281 is a memory address that tells the VIC chip what the background color is, and 53280 does that for the border. We're going to clear the screen. We'll go white, and let's see if we can draw like a road. So we'll go down like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spaces. We're going to change our color to green. We're going to turn reverse video on, and we'll draw, I don't know, this many spaces, right? And then we'll press enter. So that's going to be like a road that we're going to drive on. Okay, so let's go through the motions here. First, we want to turn the sprite on. So that was 53269, and we'll feed that a 1. And this is turn sprite 0 on. All right. We want to move it so we can see it, and we'll just do 53248 for the X address. We'll move it to 50. All right, and we'll just say sprite X. And then we're going to move the Y, which was at 53249, and we'll make that 50 also. Then we'll read the sprite data in. So we're going to say for n equals 0 to 127, because we're reading in 2 sprites worth of data. We're going to read a byte from our data statements. We're going to poke 832 plus n comma a, so we can read that into that tape cassette buffer for our sprite data. And then we're going to say next. And we will set 2040 to slot 13. And we'll just use the word slot. Now, I'm not quite sure what the call does, but slot seems like a good description for it. And again, that's 13 times 64. And that means that the memory address will be at 832, which explains why we're poking that data in 832 and just the line above. So if we run this, if all goes well, we'll have a black screen, and we should see our car somewhere on it. And there it is. So we need to turn multicolor mode on. So let's list this program out here. And let's add a line here at 80 to turn on multicolor mode. And if you remember from before, multicolor mode is done at 53287. I'm going to set that to 1. Multicolor mode. And let's see what colors we get by default. Oops. I think we have the wrong address there, and we do. It's 53276. All right. So let's run this. And now we have multicolor mode. Now we just got to kind of finagle the colors a bit. So let's get the right colors here. Let's poke 53285. This was one of the shared colors. Actually, we'll leave that as... Let's leave this as white. And then we'll poke 53 286. This is the other color. I think we had, yeah, purple's okay. And then the third color goes into 53 287, and this will be red. There we go, we got our colors. So let's add that to our program. All right, so let's list our program here, and we'll add it around line 90. We're gonna poke 53 285, 1, 53 286, 4, and 53 287, 2. All right, now we're getting somewhere. So now let's move our card down a bit. That probably needs another, let's move it down another 50 points and see if we can get close. Let's see if we can get a little closer. How about 120? That's a little too much lower. 115. Yeah, 116 maybe. That looks good. So we'll do 116 for the Y address. All right, we've got a car on the screen and it's on a road. Let's see if we can get it to drive forward. So let's make a little for loop here at, say, line 100. And we're just going to move the X position over 1 in a loop. So we'll do for X equals 0 to 255. And then we're going to poke 53 248, X, and next. This should animate our car. Cool. Cruises right along. Not too bad. We could probably make our road longer for now, but that's okay. We'll just leave it alone. So now that our car is moving, but still only using the first sprite frame, let's see if we can get it to alternate frames so it looks like the wheels are moving. So let's see how we can do that. So we'll list to 100 here. So we're going to change this loop around a little bit. Well, we will definitely keep moving the X along. And we're going to make a variable called I, and it's going to equal 1 minus I. That way that number will toggle between 1 and 0 for every iteration of the for loop. Well, it defaults to 0, so 1 minus 0 is 1. The next time it comes through, 1 minus 1 is 0. The next time it comes through, 1 minus 0 is 1, and it goes back and forth. And then we're going to use that value in 2040. So it's 13 plus I. This way it goes between slot 13 and slot 14 between our two frames. And then we'll just add a next right here. So if all goes well, we should see a somewhat animated car. There we go. Like I said, I'm a bad artist, but you could clearly see the two frames animating. So let's add a roadblock or something here. Maybe I'll add a little spot like that. So let's take a look at the piece of code here that adds our road. And what we're going to do is go back into quote mode. I'm going to go up, left, we'll go to yellow, and we'll put a space here. So we're going to have like a little barrier, right? And what we want to do now is while our car is driving towards the barrier, we want our program to stop when it hits the barrier. So we need code to detect that. And then we'll have our program stop. So how do we test for collisions? Well, it's actually really quite easy. So in our for loop, we're going to take this out. There's a memory address, 53279. And this is a register which keeps track of all the sprites and whether or not they've collided with something in the background, meaning any character on the screen. So bit 0 will turn 1 if sprite 0 has touched something in the background. This register works in an unusual way. Once you read it, it resets back to 0. So by default, it's as if something collided with it. So before you even look at it, you have to reset it. So for example, if I look at it right now, I'll clear my screen here, and I take a look at the memory address 53279, I'm going to get a 1, right? But if I read it again, it turns to 0. So now it's ready, and you'll see that it's 0. But if I move over here and I type something with a sprite, so clearly it's collided with some text, now it's a 1. And of course, it'll stay 1 because the text is still there. But we need to look at this value before our sprite gets animated, so it's reset. So 53279. So before our loop starts at line 90, right here, we're just gonna say x equals peak 53279. Now, when you peak something, you have to assign it to something or print it. So we're gonna assign it to a variable that we don't care about, which is x. Now our loop runs. It increments x, it moves the sprite over with our poke 53248. We toggle which sprite frame we want to use. And right here, we're going to add a piece of code to detect if we've collided with something. So if peak 53,279 is greater than 0, then we'll go to 500. That's going to be a line of code where we're going to crash. All right, 500, we're just going to print quote, print quote at the top, go to yellow, and we'll type in crash. And our program will end. So very, very simple. Here goes our car driving along the road. He's going, and it crashes. So we've detected a collision in the background. There's another memory address that also detects sprite-to-sprite collisions, but at this point, I think we've covered enough basics that you should be able to move forward and write your own programs with sprites. Once again, thank you guys so much for watching these videos. I truly appreciate it. I'm always amazed by how many people come and check these videos out. So I'll see you guys around. Take care.